All right. The problem that we're looking at is on the is it acidic or basic question, dealing with titration. So if we take a look, start by whoops, did that really just happen? That's pretty cool. Let's start by just getting the equation written. All right, so it looks like the titration is going to be HCl reacting with aluminum hydroxide. All right, so let's show that. Let's go HCl reacting with aluminum hydroxide. All right, we've got neutralization here, so we know that water is going to form, and the salt in this case is going to be aluminum chloride. All right. It looks like we need to balance it. My chlorines are bad, so we can put a 3 here. All right, and now my hydrogens are off, so if we put a 3 here, now there's 6 H's on each side, and we're balanced. All right. Taking a look at the information that we're given, it looks like HCl is going to be described as 0.925 molar at a volume of 0.0350 liters. My aluminum hydroxide in the problem is described as being 0.752 molar at a volume of 0.0430 liters. All right. And then as we look at the question, it doesn't want a numerical answer. It just wants to know, is this going to be acidic or basic afterwards? All right. And what we had mentioned in class is that it's kind of interesting because it's a neutralization reaction, so it technically shouldn't be either. But if one of these dudes hangs out after the reaction is completed, it is going to push the pH towards one of these options. So it's really a limiting reactant problem. So let's take a look at what our mole counts are for each of these guys. We know that since molarity equals moles, over liters, that if we manipulate that, that moles equals molarity times liters. So this multiplication here will solve it. So for my acid here, I get 0.0324 moles, all right, and that's of HCl. For the base, as I run it, I get 0.0323 moles of aluminum hydroxide. But here's where this problem differs a little bit from the example in class. It looks like the aluminum hydroxide is less, which would be our limiting reactant. However, this is not a 1-to-1-to-1-to-1 mole ratio. In this case, I need to take into account the fact that I don't need just 1 mole of HCl to make it run. I need 3, all right? Which means if we were to actually do this step, like what I do is I just say, okay, I need to divide this number right here. I need to divide it by 3 to get the true number. But what's really happening there is we're going through this step of saying, okay, well, there's this many moles of HCl, and I'm trying to figure out how much product it makes. So I would go from moles of HCl to moles of one of these dudes. Doesn't matter which one you pick. But I could say, okay, well, I'm going to go to moles of aluminum chloride. I would make the diagonals match. And then what would happen when figuring it out? Well, suddenly this would be my factor. All right? And look what it's doing. It's dividing it by 3. So anyway, you can do that, but the shortcut to just remember is to figure out how much is actually going to be produced on the other side. You can divide a raw total here by its own coefficient. So anyways, these two numbers are basically the same, almost. So if I divide one of them by 3, it's going to get much smaller. Therefore, this must be the limiting reactant, which means this must be the excess reactant. So the excess is basic. So suddenly, this is going to be basic overall.